Hi everyone, welcome to my channel. I'm Solaya Vijay, a civil engineering student at Northwest Summer State University. In this video, I will be walking you through 6 topics with simple explanations and easy problems. Let's get started. So now we are in our first topic, which is the area computation. To find the area under a curve, we use definite integrals. If a function y is equals to f of x is above the x-axis between x is equals to a and the other x is equals to b. So the area is going to be from a to b f of x dx. So this is our formula. So this is our example. Find the area of the region bounded by the curve y is equals to x squared from x is equals to 0 to x is equals to 4. So first is we need to draw a figure. So we have a y is equals to x squared, so the graph will going to look like this. But we want to find the area of the region bounded by the curve from x is equals to 0 to x is equals to 4. So, maging ganito lang siya. So, here is 0 and here is 4. So, we need to find the area of this triangle. So, f of x. So, using the formula, the area is going to be the definite integral from a to b f of x dx. So, we need to substitute the limits of integrals to this. This is the a and this is the b. So, and remember that y is equals to f of x, and based on the problem, y is equals to x squared. So it's equals to x squared. So now we're going back to our formula. So going to substitute na a is 0 and b is 4, and f of x is, need to substitute this to x squared dx. So now we're going to use the power formula. So it's going to be 2 plus 1 is 3 over 3. And now we're going to evaluate it from a to b or from 0 to 4. Now we're going to plug in first the 4. It's going to be 4 cube over 3 minus, now we're going to plug in the 0. So 0 cube over 3. Now we need to solve it with our calculator. So 4 cube is 64 over 3. And this is now it's going to be 0. So our final answer is 64 over 3. So this is our final answer. So now we are in our next topic, which is the centroid. The centroid is the center of mass or balance point of a region. To find the x-coordinate of the centroid, we can use this formula. So, which is A is the area under the curve, and f of x is the function you are rotating or analyzing. So we are so nine, two, three. So here's our example. Find the x-centroid of the region under y is equals to x from 0 to 2. So first, compute the area. The formula of the area is a is equals to the different integral from a to b f of x d dx. So we all know that our y is equals to f of x, and based on our problem, the y is equals to x, so it's going to be equal to x. So we're going to substitute this to our formula, and we also need to substitute our limits of integral from 0 to 2. So so now it's going to be from 0 to 2 f of x, it's now x dx. So now we're going to use the power formula. So x, we're going to use the power formula to x, so it's going to be x squared over 2. And now we're going to evaluate it from a to b or 0 to 2. So first we need to plug in the 2. It's going to be 2 squared over 2 minus 0 square root of 2 over 2. So now it's going to be 2 square root of 2 is 4. Divided by 2 is 2 minus 0. So our area is 2. So this is our area. So now need to we need to move on to find the centroid. So we're going to use the formula what I said earlier, which is the x is equals to 1 half no, it's 1 over a integral from 0 to 2 x dx. Oh no, it's x f of x dx. So now we're going to substitute what we solved earlier. So 1 over the area is 2. So it's going to be 1 over 2 the integral from 0 to 2. Copy the x. The f of x, the value is x dx. Or simply we can make this x squared na lang para mas madali, di ba? So, x squared. So now we're going to use the power formula again. So 1 over 2, copy the x. 2 plus 1 is going to be 3 divided by 3. And now we're going to evaluate it from 0 to 2. So let's substitute it. So now we can simply, pwede din na natin i-substitute yung 0 kasi maging 0 din naman siya. So just simply ignore it. So 1 over 2 times, substitute the x to 2 cube over 3. So now it's going to be, this answer is 4 over 3. So here is our final answer. So now we are in our third topic, which is the volume. So to find the volume, when an area is rotated around the x-axis, we use this formula. So V is equals to pi, then the integral from a to b, f of x squared dx. So you square the function because you are creating circular disk of radius f of x. So here's our example. Find the volume when y is equals to x from 0 to 2 is rotated around the x-axis. So we need to use the formula what I said to you earlier. The v is equals to pi, the integral from 0 to 2, since from 0 to 2 man, then f of x squared dx. So now we're going to substitute what is given to our problem in our from our problem. So copy the pi, integral from 0 to 2. The f of x is equal to y, then y is equals to x. So it's going to be x. Since we have squared here, so it's going to be x squared dx. So now we're going to use the power rule. So now it's going to be copy the pi. So x, 2 plus 1 is 3 over 3. And we need to evaluate it from 0 to 2. So now it's going to be copy the pi, 2 cube over 3. Next is copy the pi. So it's going to be 8 over 3. So need to multiply it by pi. Or I can simply just write this 8 pi over 3 cubic units. So here's our final answer. That's so basic. So we are now in our fourth topic, which is the length of a curve. So to find the length of a curve y is equals to f of x, we use this. So it's like using the Pythagorean theorem over tiny curve segments. So here is our example. Find the length of y equal to x from 0 to 3. So first we need to write our formula first. L is equals to the integral from a to b, the square root of 1 plus the derivative of f of x squared dx. So next is we need to substitute the value na meron sa ating problem. So the integral is from 0, since a is equals to 0 and our b is equals to 3, and then copy the 1 plus the derivative of x is 1, so it's going to be 1 squared dx. Next is solve what is inside the square root, so just copy this. So it's going to be 1 squared is 1 plus 1 is 2 dx. So now we can now integrate this, but first we can put the constant outside in front of the integral, so it's going to be like this dx. So now we can integrate it. It's going to be it's 2x, and then evaluate from 0 to 3. It's going to be 2. Why always like this? So 2 times, we need to plug in the 3 minus the 0. So it's now the square root of 2 times the square root of 2 times 3, or simply like this. So here's our final answer. So we are now in our fifth topic, which is the area moment of inertia. This measures how a shape's area is distributed around an axis. Important in engineering. To find moment of inertia around the x-axis, we use this formula. So this works for function from y to 0 to y is equals to f of x. So here is our example. Find the inertia of the region under y is equals to x from 0 to 2. So first we're to write first the formula. So here is our formula. So we need to substitute lang the value that meron ng ating given, I mean our problem. So going to be like, so the value of our a is 0. Now the value of our b is 2. Copy the 1/3. So our f of x is y, so the y is equals to x is going to be x cube dx. So now we need to, I know it's triple, it's not 1/2, it's 3. Okay, sorry, so it's 3. So now we can simply put the constant in front of the integral x cube dx. Then we can now use the power rule. Copy the 1/3. X 3 plus 1 is going to be 4 over 4. Then evaluate it by from 0 to 2. So then it's going to be 1/3. Substitute the x with 2. So over 4. We can just like, pwede din natin i-substitute yung 0 kasi maging 0 din lang naman. So just solve it. 1 over 3, 2 is 16 over 4. So our final answer is simply 4 over 3. So here's the solution. So we are now in our sixth topic and last topic, which is work. To compute work to pump liquid upward, we can use this formula. W is equals to the integral of a from a to b. This is the this is the density of the water, which is has a constant value, which is 1000 kilogram per meter cube, and this is the the gravity, I'm so sorry, and this is the area of tank surface, and this is the final height and the current depth. Okay, so I already explained everything in the formula, so let's move to our last example. So here's our example. A tank has water up to 2 meters. Area is equals to 1 meter cube. How much work to pump it all to the top? So first we need to write our formula. So here is our formula. Now we can substitute all the given. So since it's based on our problem, water up to 2 meters, so it's simply like 0 to 2, from 0 to 2. So the value of this is 1000, since it's already constant, the density of the water. Next is the value of this is 9.81, and the value of our a is 1, and then our height is 2. Since we don't know pa yet the value of y, we just need to copy the y and dy. So next is multiply these 3, and after you multiply, we can already put it in front of the integral. So it's going to be 9810 from 0 to 2, and just copy 2 minus y dy. So now we can integrate this. So just copy this, the constant, and then the integral of 2 is going to be 2y, and the integral of y is going to be y squared over 2. And then don't forget to evaluate this. So now we can evaluate this. Just copy the constant, then 2 times 2 minus 2 raised to the power of 2 over 2. So, pwede din natin i-substitute or i-plug in yung 0 kasi maging 0 din naman siya pag i-multiply na. So, we can simply just use this. So, just copy first this, 10,810, and going to be 2 times 2, 4, minus 2. So, it's going to be 9,810 times 2. So our final answer is 19,600. Oh, don't forget the unit. So it's going to be J. So this is our final answer. And thank you for watching. I hope you like it, and I hope it helped you to better understand these key topics in integral calculus. Thank you.